guys there?
Yep.
Yeah.
I'm here.
I'm just checking the sound levels to see how you guys sound.
Okay.
All right. This is me. How do I sound?
You sound good.
I can hear you now. Yeah.
You sound good. Okay, so I'm going to start by reading the intros. And if I say anything that's incorrect, stop me and I'll correct it, okay? So
Sure.
you're welcome. You're each welcome to jump right in. But these are the intros, the official intros. And, actually I was criticized by several people over the years for like, your intros are too long, and then somebody recently said it was a vibe killer. And you know what? I wish they were longer. It's important to me to establish the credibility of my guest ahead of time because there's so many people out there with no credentials and no credibility that are speaking. And I like to lay it all out there. I want to know who I'm talking to, and I want the audience to know who they're hearing and why they're worthy of being interviewed. So, Dan, I've got a lot on you. Darren, I've got what you sent me, but if there's anything to add, we'll add it here. So, here I go. You guys ready?
There's nothing more. I think we got it covered for me. Yeah.
Okay. But like I said, the more the better. I want it all. Okay. So I'm going to start.
How long will this go for about? Will this go for about an hour or so?
Yeah. When
Okay.
we're done, we'll stop. Okay. All
Sounds
right. This is Laura London, and you're listening to the second episode of the new quarantine edition of Speaking of Jung. In this new series, I'll be recording informal discussions with my friends on their areas of expertise. These talks will be candid, explicit, and unedited. Joining me today are my friends, astronomers Daniel Joyce and Darren Drake. Dan Joyce studied chemistry and political science at Marquette University and was enrolled in their Navy ROTC program when everything got interrupted by a skiing accident. After 14 months in a cast and a brace, he was told by his doctor to find work to help recover from his leg injury. That catapulted Dan into a lifelong career in astronomy. He has been a member of the Chicago Astronomical Society since 1970 and served 7 terms as president and continues to sit on their board of directors. He is a founding member of the Northwest Suburban Astronomers and became an original member of the Chicago Society for Space Studies, a local chapter of the National Space Society, formerly the L5 Society. He became a life member of the Peoria Astronomical Society in 1987 when he completed the primary mirror of all 101 pounds and 5,200 times the light-gathering power of the human eye that it is for their Jubilee Observatory site. He has worked on various telescope designs at the Adler Planetarium optical shop, where he continues to make high-precision optics. His claim to fame is the... What was the size of the telescope for Lucas?
It was a 10-inch. I want to interrupt 1 second. I don't continue to
I knew you were going to catch me on that. It just sounded better. I know. We'll get into that later. Okay. His claim to fame is the 10-inch telescope he made for movie director George Lucas. For the last 15 years, Dan has been a member of the Chicago and Northern Illinois chapters of the American Meteorological Society. He was a student of WGN-TV's Tom Skilling, studying the weather from the standpoint of the forecaster and how to recognize severe weather. He once provided details on an errant Soviet spy satellite, and since then has been Tom's astro go-to guy, eventually becoming the writer of the daily Planet Watch column on the Chicago Tribune's weather page. Dan continues his work as a weather spotter and storm chaser. He has taught astronomy and the weather at the College of DuPage for 25 years and is a former program presenter at the Cernan Earth and Space Center at Triton College. Darren Drake earned his Bachelor of Science from Illinois State University, where he specialized in astronomy. He has taught in Chicago area schools at the secondary and collegiate level for the past, 30 years?
It's about right, yes.
For the past 30 years. He is the former planetarium show operator and outreach educator at the Cernan Earth and Space Center, home of a 93-seat planetarium located on the campus of Triton College in the Chicago suburbs, where they host star parties and a monthly skywatch. The Space Center was named after NASA astronaut and last man on the moon Gene Cernan, a native of nearby Bellwood and Maywood, Illinois. Darren spends every summer at Camp Eberhart in Three Rivers, Michigan, where he acts as resident astronomer at the Yarger Astronomy Center, where he gives campers the opportunity to discover the inner astronomer in themselves. His passion is in sidewalk astronomy, setting up telescopes on the street for passers-by in downtown areas. He owns an 18-inch reflector telescope and is active and well-known in astronomy outreach throughout the Chicago area. This episode is being recorded on Wednesday, May 6th, 2020, through the magic of Skype. Hey guys.
Hello.
Jump right in. Where should we start?
Well, it's kind of too bad that right now, Darren and I being interested in outreach and showing off the night sky to people, whether it's sidewalk astronomy, as we call it, or whether it's a formal event at one of the nature centers nearby. With this coronavirus around,
Right.
We can't do that.
Yeah.
And so I'm very disappointed.
Well, I'm glad you mentioned that.
Doing that. Yeah.
Yeah, I'm glad you mentioned that because one of the reasons why I wanted to have you two on the show today is because a lot of people are spending more time at home, if not all their time, and there are things we can do from home. And you don't have to have a telescope. I mean, it's great if you do, but I'd like for you both each to tell the audience. I mean, we were in getting ready for this episode, we were kind of overwhelmed with all the different topics we could cover. And one of the things that you've both, or maybe it was Darren, taught me is how to use apps on my phone, on my tablet. And I mean, you guys know where I live. I don't want to talk about it publicly, but there's a lot of light pollution in Chicago, and I don't have any outdoor space. And so there are things that I can see from my window that just blow me away. You have to know where to look and when. So I want to first at the top, in case we lose anybody, talk about what people can do in this lockdown on their own with their phones or with their computers.
All right. If I might, say 10 or 20 years ago, if someone was interested in getting in the hobby.
And this is Darren talking, right?
Yes.
Okay.
I would tell them to get maybe a book on the night sky and a pair of binoculars and get out in their backyard and practice learning the night sky with the aid of star maps. But today, it is quite a bit of a different story, as you can use your phone and apps that are free, and they can move on all the way up to pro versions that let you literally hold the phone up and see the night sky as you would see it on a star map as you hold your phone up to the sky. And so you can wonder what a particular bright object is up there and hold the phone up, and you would instantly see that it's, say, a planet, Jupiter or Venus, or it could be the bright star Arcturus or something like that. So you really don't even need to buy a star map anymore. Just familiarize yourself with some simple phone apps. There's plenty of them out there.
What is an example of a free app? Because I had that one when I used to use the Starbucks app. They would send you a link to a free app once a week. This was a few years ago, and I loved that app. I don't remember the name of it.
I'm not sure what you had, but the one that I found that I just need no more to search, it's called Sky Safari. And there is, I believe, a free version, and there's several levels above that. And I use the pro version that can do so much, it's unbelievable. It can even control my telescope wirelessly. And so Sky Safari has the ability to, among other things, match the night sky as you hold it up and show you what you're looking at. And it would work in the daytime. It would work indoors. It doesn't matter. It will know what direction your phone is pointing and show you literally what stars or constellations you're aiming at as you hold the phone up. And it will even go through the ground if you imagine looking below the horizon. So that's one really good way to start by learning the night sky by using one of these phone apps. And the one, again, I use is Sky Safari, but I'm sure it would be very easy to find any number of other versions or apps that are similar out there.
Yeah, a little bit more on that topic. You can actually improvise and place a slot on your telescope, say near your focus mount, and place the phone in that slot and use it as an aiming device for your scope, like a finder scope. For instance, if you're in light-polluted skies and you want to show off in the telescope an object we call the Beehive star cluster, it's in Cancer. We know it's roughly halfway in between the brightest stars in Gemini, which are Castor and Pollux, and the brightest star in Leo, which is Regulus. But if you have this phone with that app on it, and it's brought it in so it's connected to where the telescope is aiming, similar to a finder scope, you can wander through the sky, aim it in that general direction, and it'll point it out to you exactly where it's at.
Now, is there an at-home telescope that you guys, either of you, would recommend? Maybe people can find on Amazon, like a cheap one,
yes.
and then eventually we'll talk about the huge ones that you each have. But what would you recommend?
Yes. I recently got a call from my friend Greg at Celestron to write up a review for a new technology telescope that they're offering. It's a low-budget telescope for beginners. And I jumped on it. I got it and wrote a review up. And what it is it's called the Celestron StarSense DX. And you can get either the reflector version or the refractor version for in the neighborhood of $300 or $400. There's a couple of different choices. But the main idea is built on what we've just said, only it goes a couple steps above. It lets you literally mount your phone on the mount of the telescope. And in it, there's a mirror that reflects into your camera.
Okay.
And the app that you download will take a picture of the sky in real time and therefore tell the telescope exactly where it's pointing to high precision. Mm-hmm. And if you put that you want to look at a particular object, such as the beehive or any other one of many hundreds of objects, it will tell you exactly how to aim it with arrows. And then as you zoom in on it, it continues to take pictures of the sky and compare it to pictures in its database and do what it calls plate solving. And then in real time, it will let you zoom in on the object when it gives you a green box on your phone. Mm-hmm. And then you should be able to look through the eyepiece and there will be the object. Mm-hmm. It's pretty simple.
You mentioned that it's $300 to $400, and I just want to remind everybody, everything that Dan and Darren mention, if possible, I will provide a link to it in the show notes on the website, speakingofjung.com, for this episode, which is episode Q2. So $300 to $400 might sound affordable to some people, but it might not to others. Is there any super low budget telescope out there?
That's important.
Would be binoculars.
Binoculars, okay.
Yes.
And the answer. Yeah, go ahead, Darren.
Okay, the answer, and that's a good question. It's important to point out that about 95%, this might come as a surprise, but about 95% of all telescopes that people have are junk.
Are junk?
They're really, yes, believe it or not, they're very difficult to use. They're very low quality in every way.
Yeah.
Wobbly tripods, low quality eyepieces, hard to find and point things at.
Yeah.
And they end up being a source of frustration more than anything. Yep. And people can lose interest in the hobby just because they bought what they thought was going to be a good telescope because it might have cost $200, which sounds like a lot. But the answer is to really get a telescope that is going to grab you and get your attention and and B, something that's going to carry you on into the future, you're going to have to spend more than $100 or $200 in general.
Okay.
Yeah.
So
there are ways around that, like by buying used on Craigslist, but that's a slightly different direction. But it is important to know that most people have telescopes. When they tell me they have a telescope, and then I ask what kind they have, they start to describe something that is not a quality instrument.
Like a toy. When I was a kid, I had a telescope, but it was basically a toy, and I couldn't find anything.
Right.
Exactly. That source of frustration is very, very common.
So, Dan,
that's one of the best ways of. I'm sorry, just
go ahead.
To point out that if you don't even have to join these local astronomical societies. You can just go to their meetings or maybe one of their public events whenever they get going again, because we're shut down by coronavirus right now. But if you can join up with one of their events, whether it's a meeting or whether it's one of their public outreach events at one of the local maybe nature centers, you can check out what telescopes are there and see what might fit your needs, because they're readily going to tell you how much was put into it, whether they had to work on it themselves. In some cases, we do all the work ourselves. We make them ourselves.
Which you do, right? And you had mentioned binoculars. So would you tell us the difference between what you're able to see with binoculars and what you're able to see with a telescope? What's the difference?
All right. Well, a pair of binoculars will have what we call high light concentrating power, because they don't over-magnify. And they're looking at larger chunks of the sky at once than a telescope. So it's easier to track down what you want to find. Now, you're not going to see a very big image of what you actually track down. But for many of the objects in the sky, that's not really a big problem. For instance, the Andromeda Galaxy spans a length about 9 moon diameters across. That's really big. Mm-hmm. But you have to have dark enough sky to do that. Otherwise, you're probably only going to see the internal core from around the city. But because it can concentrate the light down harder than a telescope can, sometimes it can show things quite a bit more with quite a bit more detail, and surprising amount of detail compared to what the telescope will do.
Really? Like if you're looking at Mars, let's say, and you want to see the polar ice caps or dust storms.
Well, that you have to have a telescope for. The planets you have to have a telescope for.
Okay. Yeah. But the stars, constellations.
But the stars, yeah. For instance, the Sword of Orion, you look at the Sword of Orion, has a so-called Great Nebula in it. And it's a beautiful binocular object.
Wait a minute. Why are you? Wait. Tell us why you said so-called.
Did I say so-called?
Yeah, I was just wondering if there was some controversy over the nebula in Orion.
No, I'm not trying to say it's controversial. It goes by a number of names. That's why I'm saying.
Got it. Right. Okay.
Yeah. In any case, though, it's a beautiful region to explore with binoculars, and you look up a little bit higher and you see the belt of Orion, and there's some showpiece stars in that region. There are quite a number of them. They're fairly bright, in some cases fairly colorful.
And one thing one thing you guys taught me, I think it was Darren, whenever I would mention to you the name of a star, you'd say, well, that's a binary star, which means that there's 2 stars there, and it looks like one from our vantage point on Earth, right? But there are really 2. And that's the case with Sirius. So Sirius is the brightest star visible from Earth. Is that right?
Yeah, except for the sun, of course. Yeah, it is.
But it's a binary system.
It's not only the brightest, but it's the closest nighttime star you see naked eye at our latitude. It's about 8.6 light years away, which is twice the distance of Alpha Centauri, but Alpha Centauri never gets above our horizon. Okay. And yes, it's a double star, but it's a very different one, because its companion, which is very faint and 10,000 times dimmer, is a white dwarf. And you can actually see from one decade to the next, the white dwarf gets slightly closer or slightly further from Sirius, with high magnification in a good telescope, you will not see the companion with binoculars. And most stars, when we talk about doubles, are telescope doubles. So you would need more than the 7 or 10 power that binoculars give you.
Right. But would you be able to see that Sirius is a double star with a low-budget telescope, or would you need something very high-powered?
Generally, many doubles that we would mention, you can see it with a low-power telescope. But in this case, it actually depends on what decade we're in. About 15 years ago, you would have needed not just a high-quality 10-inch telescope, but you would have needed very steady conditions, very not just transparent, but a steady atmosphere. The reason we put the Hubble Space Telescope above the atmosphere was because of the blurring effects. But you could look with the best telescope under bad conditions and not see the companion.
Yeah, that's interesting.
Go ahead. You can see the faint companion, a white dwarf companion, with probably a 6-inch telescope without any trouble. But 15 years ago, in its orbit, it would have been closer, and you would have needed a bigger telescope. So you can actually see the motions of some of these double stars over years or decades, just a slight difference in the position, angle, or the separation. So currently, you would not need a biggest telescope to see the companion right now. But 20 years ago, it would have been different.
Okay. And how large is that low-budget telescope you mentioned earlier? How many inches?
You could get, well, today it's a different story than, say, 20 years ago.
No, I mean the one that you said that you wrote a review for, the new Celestron telescope.
Oh, that was a 4-inch lens, and it is not the highest quality telescope. I would doubt you would see the companion with that telescope. The lens is not a high quality color field type lens.
So
there's
Dan, Dan, tell us, you make telescopes. Tell us what goes into making the lens of a telescope briefly. Tell us briefly.
Well, you want to find a disc of high quality glass. Pyrex, what we call low expansion glass. It's not going to get stressed and lose its shape over time. You want it to be really good and steady. The most choice glass is what we call the ultra low expansion glass, the so-called ULE, which is a type of refined quartz. In any case, though, you take whatever size you can find on the market. There's an outfit in Massachusetts which does a really good job of this. And you have to have now grinding and polishing equipment as well.
But you get a chunk of glass or a sheet of glass?
It's a disc.
A disc of glass.
It's either 6-inch diameter, 8-inch, 10-inch, 12.5.
So you buy the round piece.
You buy the round piece, right. Now, presumably you're going to have a tool. The tool can be plate glass or it can be ceramic. And you're going to have to understand that you're going to have to rub the two discs together using a rough grinding grit. Usually we use what's trade name is carborundum. It's silicon carbide. It's very, very hard. It's a very hard substance. I believe it's the hardest after a diamond. In any case, though, you grind the two together, and it takes many hours. And you have to use a particular technique in developing the curve. You need a concave curve for a telescope mirror, which is the kind we usually make. We're not into making lenses. We're into making mirrors, the so-called Newtonian style. It was invented by Isaac Newton many centuries ago. This particular design. In any case, you then have to get it through. Not after you've rough ground it. It has a very rough surface. So you have to go through finer and finer grades of the silicon carbide until you reach a point where you can use microgrit, which is aluminum oxide, another very hard substance. But it's down into 15 micron, 9 micron size, even go down even to 3 micron. This is even finer than powdered sugar. And you're rubbing the two discs together, and now it becomes polishable. And you want use a glass or a ceramic substrate for what we call refined pine tar pitch.
Okay, I think that we're getting a little too. No, wait a second. I think we're going to jump in here. I think we're getting a little too detailed because I think we're going to lose some people here. I don't suspect anybody's going to be making a telescope on lockdown. I just kind of wanted you to give us the basics so that we can understand how telescopes work. And Darren, have you made any?
I've done a couple with Dan many years ago where I refigured mirrors that were not made right in the first place, which is very common.
Oh.
And so that's one of Dan's abilities, is to take a mirror that might be, say, it's only accurate to a millionth of an inch, and we make it accurate to half of a millionth of an inch on the surface.
And that's something that we didn't cover in the beginning, how you two know each other.
Back in the fall of '89.
When I used to teach at College of DuPage back 30 years ago. And we had a class. I guess that there wasn't enough room at the college itself, so we held it at Hinsdale Central High School, the COD class. Mm-hmm. And Darren, of course, doesn't live very far from there. Now he teaches there. And he happened to be in my class. And we met that way.
And what year was that?
About 30 years ago, wasn't it?
Fall of '89.
Okay.
But we met a couple months later. If we hadn't met then, we still would have only met a couple months later, because I started working at the Cernan Center in January of '90, and he worked there already a couple of years.
He worked there.
We met at one place, but we would have definitely met again. And even if we hadn't met at Cernan, we would have met at future events called Astrofest, which is we had been going to that star party for a few years already. We would have crossed paths in many different scenarios. Yeah. So, but basically, it was the fall of '89 when I took his class, and then we continued to get to know each other at the Cernan Center, where we both worked as show operators.
Mm-hmm. And then I met Dan when I was walking out of the Adler Planetarium, which I hope we get to talk about here, which is the big, I think it's the oldest planetarium in the country. Is that true?
In the Western Hemisphere, in fact.
In the Western Hemisphere. Okay, it's located in downtown Chicago, out on the lake. It is probably my favorite spot in all of Chicago. I love it. It's so beautiful. It's the vibe there is, it's out of this world. No, it is just one of my favorite places because of how beautiful it is. And you can see the whole Chicago skyline from there, and you're on the lake, but you're still downtown. So I was walking out of the planetarium, and Dan had his telescope set up. And Dan, we were looking, so this was in June of 2016, and we were looking at Saturn, I think. Do you remember?
We were looking at Saturn, but I thought it was 2017, but I could be wrong.
You're right. It was 2017. Okay.
Yeah.
Yep.
Because I'm remembering where Saturn was.
I thought you would.
If you know the constellation it was in, was close. Yeah, right.
Right. And also, another thing I want to get to, that was the year of the total solar eclipse that crossed the continental United States. And that's another thing that we talked about that night. So I was with a couple other people, and you showed us Saturn in your telescope, which I had read somewhere, Darren, it might have been in your bio or on the camp's website, about how seeing the planet Saturn through a telescope can change a person's life.
Yeah.
It is. Go ahead.
Yeah. When I show it every summer, I run an astronomy program in Michigan every summer at Camp Eberhard. And I have my large telescope, 18-inch telescope, and we have a fleet of other smaller telescopes. And the kids come out, I'm on a lake, on a peninsula, it's perfect setting. They come out, and the first thing they see in the last few years is Saturn. I've got the telescope trained on it, because as they come, that's pretty much all they can see, because it's still not dark out yet fully. Mm-hmm. So I have to point it at the non-deep sky objects, no galaxies or anything like that yet. It's not dark enough.
Okay.
So I put it on the one object that is going to absolutely mesmerize them from the beginning, and that is to see the rings of Saturn through the telescope is something that people are used to seeing Saturn on a TV screen, a book, or whatever, a computer monitor, but not in an eyepiece where they're actually seeing the real thing.
Right.
And they tend to think that it's fake.
Yep.
They think it's a sticker that I'm trying to con them somehow because that can't possibly be real.
Yeah. And then, Dan,
I
think...
It can't possibly be real, and yet it is. I hit the telescope, tap the telescope, the image shakes, and they see that it is the real deal.
Mm-hmm.
And that is the initial impression they get when they see Saturn, because they just never, ever seen the light from the planet hit their eye before, and they see that clear view image that they've never seen before.
And the moons. Dan, I think you showed me the moons of Saturn. Is that right? Am I remembering that correctly?
That's right. So there were two moons that we could see that night. The moon Titan, and I believe also Dione were both visible that night.
Oh, right. And then we talked about the upcoming eclipse, because that night I met you was in June and the eclipse was in August. And you guys weren't together for totality, right? I was in South Carolina, which I've talked about a lot of times on this podcast, and the episode with Rick Levine, and then I was on Richard C. Hoagland's show talking about it. But where were you guys during the total solar eclipse in 2017?
Well, we originally planned on being out west in Nebraska, but that's just plan A. But you have to be weather aware, and you have to go with the best odds in the upcoming days as you see the weather charts. And we changed our plans, which was probably good because there was more moisture in the air out in Nebraska, and some people had clouds out there. So we ended up going south and a little east, and we ended up in different locations. I ended up being in Hopkinsville, Kentucky, and it was perfect. And it was the center line. It was the best location as far as seeing the most number of seconds of totality, and it was a gathering. I didn't know where we were going to end up when I left, but that's where I ended up being, and it was perfect.
So you left in your car, Darren, you left in your car with your telescope.
Yeah, I brought a 12.5-inch telescope. Well, why would you bring such a big telescope? Well, most people there, this was a big gathering, and you could tell that many people some of them were somewhat astronomy savvy, but most were not. Most people had small telescopes. But I had a powerful telescope with a 12.5-inch mirror because I wanted to look at totality at the corona with the big, powerful, high light gathering power telescope, because while you don't look at it without filters during the partial phases, the corona would be that much more amazing to see through the eyepiece of a bigger telescope. And it really paid off. I was absolutely amazed at what I saw, and I recorded my reaction, and it was just absolutely unbelievable. And in the minutes before totality, I was showing people Venus through the telescope because they became clearly visible. There it is. I pointed, people saw Venus. I projected an image onto a poster board of the phases going right before totality.
I think I have a picture of you, and I put all of the episodes of Speaking of Jung now on my YouTube channel, which is Jungi and Laura, and I have a lot of photos of both of you with your telescopes and photos of things that we're talking about on this episode, and they will be part of the YouTube slideshow that will be with this episode. So I think I have a photo of you there, Darren.
Yes. Yeah, I had a picture put on Facebook of me holding up just a piece of cardboard, really, and it showed the partial phase of the eclipse that everyone can see. That's really the best way to do solar observing with the group around, is to aim a telescope at the sun, make sure no one gets near the eyepiece because it's very dangerous with that concentrated light, but then focusing it on a flat surface, preferably a white poster board, and everybody can see what the sun looks like. And this will even show sunspot detail pretty nicely if there are sunspots.
Well, then what do you use to protect your eyes?
I have, currently I use a dedicated solar telescope called a PST, which is a small little 40 millimeter refractor with a built-in hydrogen alpha filter that lets you see a different layer of the sun. When you look at the sun, you see a visible layer called the photosphere, but this shows you a layer above the photosphere called the chromosphere, just above that layer. And it's red, and you can see prominences. Those are flames shooting off the sun, or flares, or other type of details that you don't normally see with just a white light filter. In addition to that, I also do have white light solar filters to put over regular telescopes, like an 8-inch telescope. You can put right over it, and instantly it's a solar telescope.
Okay.
So with the Mylar-coated filter, you can clearly see the sun safely and do group viewing, but you have to make sure it's well secured without isn't going to blow off or anything.
Right. Very important to protect your eyes. So we're all going to have another chance here in the United States and in North America to see another total solar eclipse on April 8th, 2024, and I will be with both of you. I'm inviting myself. Wherever you'll be, I'll be. Where will that go through the United States?
It starts down in Texas, just east of Big Bend National Park.
Where are we going to be?
Well, given that April 8th is the middle of tornado season, we're going to have to very, very carefully study the weather charts and consult with my good friend Tom Skilling as to where it's best to be.
Right. Okay.
Because there's going to be some cloud cover for sure that day.
Yeah, April showers. So it's going to depend on the weather.
Yeah.
And if the weather is clear, this is important. If the weather is clear, the closest is Indianapolis, which is only about 4 hours from here.
Oh, that's close. Yeah.
So,
it is exceptionally close. It's closer than any other part of totality of the other eclipse. And interestingly enough, the path crosses into Carbondale also, where the 17 eclipse happened.
Wow.
So Carbondale is a unique location where they get 2 total solar eclipses in just 7 years.
And Carbondale is in Illinois, is in southern Illinois, right?
Exactly.
Illinois University is in, yes.
Okay, so there is a website. Let me just get this in here. There's a website called greatamericaneclipse.com. And if you go to the page called Future, it will show all the paths of the upcoming total solar eclipses.
Right, yeah. I just want to point out that I saw the 2017 eclipse at Lebanon, Tennessee.
You're in Tennessee,
about 20 miles east of Nashville. Very close to the center line there. Now, it just happened to be on the recommendation of my younger brother, who was part of the entourage following me. My brother was following me, and a group from Wisconsin, including a nurse from Lowry Children's Hospital, were following me also. But in any case, though, my brother has a pilot's license. He recommended the airfield by Lebanon because he could get a hold of the people there and tell them, okay, we're going to bring our equipment there, and is it okay to set up? And they said, sure. And by golly, here those young people from the Civil Air Patrol came down, and they got to watch too. And it was a wonderful experience for them. And we did have a very clear sky, completely unobstructed. And by gosh, over the next hour, we saw 70 airplanes take off who had been there just because it was near the center line of the eclipse. These people had flown in from everywhere to get to that spot. And sure enough, we're looking at all these wonderful airplanes take off. One of them even wagged his wings as victory, we thought. It was great to see it from there. Now, I had my usual 10-inch scope that I usually carry around for the public observing. And this nurse who came along with, she had been recently widowed, and I inherited his telescope, which was another 10-inch, and I had both those scopes along. My brother had his own scope along, an 8-inch, very similar to it, and we had great views of this eclipse. It was really phenomenal to watch.
That's great. I'm so glad you guys got to do that. So another thing that we can see, and I want to get back to what we were talking about at the beginning of this episode, is what can we do from home, right? So, because I don't want to forget to mention these two things, and I know about them because of you both. One is how to spot the space station, which it is pretty cool to see. And even from in the city, I can see it. And then something I haven't seen yet is this Starlink chain of satellites. So I know that there are a lot of websites out there about how to spot the space station, but I was wondering if one of you would tell us briefly what the easiest way to do that is.
Yes. Heavens Above is one that I use for the Starlink satellites. And also, if I don't check, I might have friends who will tell me that it's going to happen. But heavensabove.com.
Yeah, tell us what are the Starlink satellites and what does it look like?
Okay, yes. Elon Musk is sending up droves of these satellites, sending off several dozen per launch, like every several months. And they're basically for the internet. They're going to provide free, or not free, but internet all over the world with these networks of satellites that will be covering the Earth, tens of thousands of them ultimately, which is not good for astronomy. But that's not happening quite yet. But
so how many are up there? How many are up there right now, would you say?
I don't know exactly, but it's many dozens, I think.
And they're
many.
lit up,
right? 300, yeah. There's a little over 300 of them.
Oh, is that right? And they're bright. They look like stars.
Yeah, right,
yeah,
they do.
They're shining because of the light of the sun. When you see a satellite, you see it simply because it's reflecting the light of the sun. Mm-hmm. And you can very often see them go dark as they traverse the sky. That's simply because they're going into the Earth's shadow, or they're watching sunset from their perspective. And when these are launched in the early days, they're really close to each other. And a couple of weeks ago, we saw a set of them go by that had just been launched, and we saw like 20 of them all at once, just in a small area of the sky. And it was a really, really bizarre sight. And even astronomy types, people who have seen satellites thousands of times, were like, wow, that was amazing. But over days and weeks, they separate more and more and more, and they get higher up, and they'll become a little dimmer. And then you'll see maybe one pass every 30 seconds, but in the same part of the sky. Mm-hmm. And rather than 10 every few seconds, you'd see one every 30 seconds or so. And you'd see that for like 20 minutes, just a train of them going on and on and on over the exact same time.
Every night?
No, it will become every night, I'm afraid.
Oh my goodness.
That's bad because telescope observatories that are imaging the night sky mm-hmm. will have their images ruined by streaks of light constantly going through.
And this is permanent.
See, they didn't think this through. Yeah, Elon Musk didn't care about astronomers or think this through when they were putting these up there. And it's going to be a problem for all people who do imaging, who want to take pictures of the night sky through their backyard telescopes or the observatory telescopes that cost hundreds of millions of dollars. As they do research, they're going to have these streaks of light going through their images. And it's going to be a problem that's going to have to be dealt with at some point. But
so
now, it's not a big problem, but it's going to become one.
It's going to become one as more satellites are put up into orbit. But is there the chain that passes by that's visible, is there a regular schedule to that, or does it vary like the space station?
It varies. It's not a pattern like you can say every 3 days it's going to happen. It's not like that. Go to, as far as I know, heavensabove.com. And also the Sky Safari Pro has satellites in its database, and you can see them on there after they've been launched. They update the app with this data.
Okay.
So, but for the average person, just go to heavensabove.com. That's the go-to site for looking up satellites.
Okay. And Dan, you were saying something?
The schedule for launching them can be interrupted by the fact that the weather is too bad for launching at Cape Kennedy. And so we can't tell exactly when they're going to be until they actually launch them, and that may be delayed from the original launch date because of weather problems or mechanical problems that they detect on the spacecraft.
Right. And so do you know when they're going to be finished launching all of them?
Boy, that's going to be many months from now.
Many months. Okay. And then as far as...
I think we're looking at years because I've heard tens of thousands of these are going up.
And they're all going to be connected to each other to provide internet access to the world.
They're not connected to each other more than they are connected to transmitters on the Earth, I presume.
Okay.
They'll be able to, because the way it works is if there's enough satellites blanketing the Earth in a network, it should provide any place on Earth internet ability because they keep rising, and at any location you'll be able to see a couple of these things at any time, and your device can communicate with it as long as it's above the horizon. So with this many creating this network, you can be in the middle of an ocean and be able to get a high quality internet connection in theory.
Okay. Now, as far as
it's kind of like an extended GPS.
Extended
GPS operates much the same way. Mm-hmm. It's a series of satellites, but you don't need anywhere near as many GPSs to do the work that Elon Musk wants to do. You have to have a lot more satellites to do what he wants to do with connecting with Wi-Fi. Yeah.
Yeah. And so as far as seeing the space station, which is another thing that I highly recommend, Dan, you showed me Saturn and its moons in a telescope. And then Darren, you and I were Facebook messaging, and you told me that I was going to be able to see the space station from my window, since you know where I live and where my windows face. And I saw it, and it was pretty amazing. It's not like you can see... I mean, I just was using the naked eye. I wasn't using anything else, and I saw it. So would you tell us how we can find out when it's going to be passing by? And it would be helpful if people knew what direction their houses faced, all the different windows.
Yeah. Okay, what I use is Sky Safari Pro. I don't know if the free version has the information for the International Space Station or not, but it'll tell me by running the clock forward, I can see if it's going to appear on any night coming up. It's going to be clear tonight, and I didn't check tonight. It would have probably been a good idea, but so I'll see, hey, it's going to be coming up in the southeast and move this direction, and it's going to be exactly 80 degrees or whatever above the horizon, and it'll be bright, maybe about as bright as Sirius or brighter even.
Is it always at that brightness?
No, if it's going to be clearly in the sunlight without the hindrance of the Earth, and it's nearly overhead and dark, pretty much it's going to be Jupiter type brightness. If it's only going to be 12 degrees above the horizon, it'll be more like a brightness. But its precision can be quite high with these. And I've actually seen a satellite or the projection of where it's going to be. And I said, it's going to pass near this star. And then I would actually put my scope on that star and then watch the satellite go through it. And I've seen that happen. And I've even been able to follow it many times with my telescope. And you can see the shape of the satellite with its solar panels and all that pretty easily by following it with the telescope. So it's not just a point of light through a telescope, and you can actually see fine details if you can track it accurately enough. But to the eye, you will never see more than just a dot.
A dot. And then it disappears. Tell us why you'll be watching it and it's moving and then it'll just disappear.
Yeah, it's true with any satellite. When it goes into the Earth's shadow, it just it appears to go away. And the reason you see it is that the sun is shining on it. It doesn't have a light source aiming down. It's simply reflecting the light of the sun. So when it goes into the Earth's shadow, and this isn't an instant thing because of our atmosphere, it might hit a sunset type atmosphere and then maybe get slightly reddish. And then as it goes into the shadow, it'll pretty much go away fairly quickly. But they tend to dissipate over several seconds because it goes through a thick atmosphere for a few moments and then disappears completely into the Earth's shadow, and then it's completely invisible.
Mm. And this is visible from pretty much everywhere in the world, right? I mean, you just have to know when it will be visible in your area. And there are probably websites out there. I'm sure there's a page on NASA's website that will tell you that. You don't have to have Sky Safari, but that is the app that Darren uses and now I use.
Or Heavens Above is a website you can go to. And oftentimes, if I have Facebook friends, I will put it out. If I just happen to notice it's going to be clear tonight and I check it, I see, it's going to be up tonight. And I'll actually put out an announcement on Facebook. And then a lot of people go out and see it because I did that. Right. And so you can, if you're connected to somebody like me or Dan, you can find these things out in advance because we check these things a lot.
Right.
But if you aren't, then you can go to heavensabove.com is the primary source that I know of that will show you, you put in your location or it will know your location. And then it shows the details as to where it will come up, where it will be at its highest point and how many degrees it will be. And then when it will be low again. So Heavens Above is what I would recommend.
Okay. And speaking of disappearing, I would like to ask both of you about Betelgeuse, or as it's commonly called, Betelgeuse, which is the star, the very bright star that forms the upper, is it right or left? Is it, as you're looking at it, it's the left shoulder of the constellation Orion?
Yeah.
Right. And so that star is very bright and it's been dimming. Now it's no longer dimming. I follow a Twitter account called Beetlebot, which it's kind of difficult to understand. It's a chart, but it's been brightening again. Darren, you mentioned that it was. It's a big deal. So would you tell us about that?
Yeah, a fair number of stars up in the sky are not a constant brightness. And this would even include Polaris, the North Star. But the variation in brightness is minuscule, and you won't see it with the naked eye, night to night or year after year even. It's subtle. You would need sensitive instruments to see these changes in most cases. And Betelgeuse is one of those. It's a red supergiant type star, about 400 or 500 light years away. So we see light from, say if it's 500 light years away, it's 500 years old light. And it's a very large star. It's so large that if you put it in the place of our sun, the Earth would be inside of it. And even Mars would be inside of it. That's a very large red supergiant. So these type of stars also slightly vary in brightness because they get bigger and smaller. They're not the same constant size. And the variation in Betelgeuse is very slight. In periods of like months or years, it can change very slightly. However, in the last several months, people were noticing it was getting quite dim.
Yeah.
And by 10 or 20%, not dramatic, not like half the brightness, but maybe 20
it was
or 30%.
Noticeable. It was really noticeable to me.
And yeah, it was noticeable. But it was, so that made it a fairly rare event to see it do that. And people were speculating, it's about to explode.
Yeah.
But it will go and explode as a supernova any 10,000 years now. But it's not likely to happen in our lifetime. It's possible, but it's very unlikely. But it would be amazing if it did. And maybe this was a precursor that it was going to.
I mean, I kind of wanted to. I want to see it.
It would be about, imagine taking the brightness of a full moon and condensing it down to the brightness of the size of a point of light, a star. That's what would it be. That's what it would be. It would be as bright as a full moon and be an amazing event. It would be absolutely amazing in astrophysics, and the neutrino detectors and gravity wave detectors would go nuts.
Wait, so it would be as bright as a full moon, but not the size of a full moon, right?
Correct. It would be the size of a pinpoint. but as bright as a full moon, about, yes.
But just a pinpoint, that's no fun.
Right.
Yeah, because it's a star that even though it's as large as the orbit of Mars, even our telescopes that we talked about resolve it only as still just a pinpoint. It's not resolvable as a disk. It's too small to see with anything except the Hubble Space Telescope, really, to see. Only it can see a slight disk. So if it explodes a few times bigger than that, it's still a pinpoint.
Okay.
And it would take several months before we might start to see a shape like a nebula start to emerge.
Well, wait a second. Since it's so far away, since it's so many light years away, is it possible that it already could have supernovaed and we just don't know it yet?
Correct.
Yes, absolutely. Yes. And I often get the question, we hear about many of these stars that they've probably blown up by now. Well, that's really not true. Most stars live billions of years or at least hundreds of millions of years, and their light only takes decades or centuries to get here. So, and most stars don't blow up. Only less than 1%, maybe way less than 1% of the stars actually blow up. So Betelgeuse is one of the prime candidates for being able to say that. Maybe it did blow up and we haven't seen its light get here yet, but the odds of even that are still pretty low.
And it's a prime candidate because of its age?
Because of its mass. It's about 12 or 13 or so times the mass of the sun.
Okay.
It needs to be about 11 times the mass of the sun to blow up. And the vast majority of stars are not that massive, and they will not blow up.
Well, speaking of blowing up, what happened to Comet Atlas? I mean, I was all excited I wasn't excited. I was sort of dreading it because the appearance of a comet is what the Tibetans call an evil omen. And I really thought it was going to coincide with this coronavirus crisis because, as Clyde Lewis said, every plague needs a comet. So Comet Atlas was one of the talking points that we had come up with a couple months ago when we decided to do this episode, but now it's a non-story. What happened?
It's comets are very, very dissolvable features. They're not solid like planets or asteroids.
They're ice, right?
They're very fragile. Yeah, they're mostly ice. They have gases. They're always lightweight, and they're very fragile. And they get near sunlight, and they can break apart.
Well, were you surprised that Comet Atlas broke apart?
Not especially, because it resembles its orbit resembles that of a comet that came by in 1844.
Okay.
Which is a really bright one, but because it's on the same orbit, it suggests that it's already a break-off of that comet.
It's a break-off of the... Whoa. It's a break-off of the 1844 comet?
Right. Yes, it could be.
It could be, okay.
Yeah, it could be. Given the fact that the orbital period is well over 6,000 years, the separation would become a century by the time it reaches us right now. It's not unusual for that to happen. Okay. They're fragile. They break up, and it's too bad.
But there is another one.
There's a comet Swan. There's also a comet Pan-STARRS around. Swan might become a fairly conspicuous object fairly soon.
When will we know about Comet Swan, if it's going to be visible?
I think before the end of this month. I think we'll already...
Darren?
It's going to go through, the 8th to the 14th, it's going to go through, I believe, Triangulum and then Perseus in mid-month, and then to Auriga. But it will be near the sun, the morning twilight. So it may be somewhat bright, maybe naked eye, but be somewhat close to the sun, which is typical of brighter comets. They tend to be very bright when they're near the sun. And
so we won't be able to see it then.
Well, I'm not saying that. It may be visible, but right now it's southerly. You have to be kind of way south on the globe to see it, but it's moving so that it will be visible from the Northern Hemisphere in the next week or two.
Well, some of our listeners are in the Southern Hemisphere, so I don't want to forget about them. So when is it possible that they might be able to see it? What would it look like in the Southern Hemisphere?
It may be visible now, but it would probably require a telescope or at least a good pair of binoculars and some ability to know the night sky.
Right.
With comets, they're the only objects that we just don't know because of how fragile they can be, like Dan said. Whereas asteroids and planets, we know exactly where they're going to be. They follow Newtonian physics perfectly. Mm-hmm. But comets have these jets. When they evaporate, they go off in slightly different directions than predicted, and then they tend to not sublimate as much as we thought they would, and their cloud, so to speak, is very dim when we might have thought it was going to be bright. And so we just don't know, especially with ones that have never been seen before, what they're going to do. And that's the case with Atlas and now Swan. But it is worth watching Swan on a website like maybe spaceweather.com. Okay. They sometimes tell if there's a naked eye comet on space weather. And that would tell you, or just a Google search could probably give you a good clue as to where to look.
Okay, we'll keep our eye on we'll be on the lookout for Comet Swan. And then what about asteroids? There was a close flyby not too long ago, wasn't there?
Yes, I tried to see it, but my telescope, using Sky Safari Pro, aimed my telescope at it, and it hit a nearby house. So it was too low to see.
Oh, your telescope hit the nearby house.
I mean, it ended up aiming at a house because it was low above the horizon in the south.
Okay.
Yeah.
So have you guys seen... Hang on. Have you seen an asteroid through the telescope, and what does it look like? How does it look different from other objects?
Yeah,
well, it looks many times. It just does, but it moves. You can see it move against background stars.
It just looks like a star, but it moves.
But it's very slow. It's a very slow motion against the background stars. Yes, that's exactly what
in general, that's
a number of years ago.
Darren?
And,
hang on. One at a time. Darren, go ahead.
Yes, I have seen a disk on Vesta before.
Oh,
it was near a bright star of equal brightness, and the star was a tiny point, an airy disk, and Vesta was maybe 50% bigger. So I was actually able to resolve the disk. But that takes a lot of things coming together to be able to see that.
Okay, hang on. So you're saying you saw Vesta, which is an asteroid near and dear to my heart because I was born with the Sun Vesta conjunction, and very close. And when you saw Vesta in the telescope, it did not appear like a star. It appeared like a disk. Is that what you're saying?
Yeah, with high magnification, like 400 power.
Okay.
And steady air, which is not a guarantee. Yeah. I was able to tell that it looked bigger than the star, so I was resolving the disk. And it's also worth noting that it is possible to see asteroids move in front of stars, and I have seen that that event happening before. Yeah, if you follow people on the internet who are occultation chasers, as you'd call it, they look for events where asteroids are predicted to move in front of stars.
Right.
You can actually see a star wink out for several seconds as the asteroid moves in front of it, and then the star brightens up again. And I have seen that event happen once. And so that was kind of cool. I never saw the asteroid, but the star was many times brighter. And so I saw a star wink out for several seconds. And that can give information as far as to how big the asteroid physically is if you have a network of observers.
Okay.
Yeah.
Is the asteroid that you were trying to see not too long ago Apophis?
No, Apophis is going to be 10 years from now.
Oh,
and it will be a big news event.
Okay, got it.
Right. Yeah.
And it will be, you said it's about the size of a football stadium, that it won't hit the Earth.
Right.
We know for sure.
It will be Friday the 13th of April 13th of 2029. It will be the size of a football stadium, about 400 meters, and it will dip below the orbits of our geosynchronous satellites and miss the Earth by 20,000 miles. And it will be visible as a somewhat bright star-like object from people in Europe moving across the sky.
Okay, but it'll just look like a bright star.
Not a bright star. It will be what's called third magnitude, which should be about 2 or 3 times dimmer than the North Star.
Oh. Well, that sounds pretty uneventful. Doesn't
it?
I mean,
it's the thought that counts on that one.
The thought that...
Because,
go ahead.
Well, it's the fact that we're so close, astronomically speaking, 20,000 miles is as near miss as you ever want to deal with.
Okay.
Yet if it hit the Earth, it would be catastrophic to any region and to the globe, actually, climate-wise, if it was to hit the Earth. And fortunately, we don't have to worry about it. But there is no guarantee that it won't hit the Earth within the next several hundred or thousands of years from now.
Okay. What is your take on Mars, life on Mars, each of you?
Well, the possibility of what we call panspermia, one object develops life, and then life spreads on that planet, even if it's just for a fairly short amount of time. An asteroid strike can hit that planet and knock the life, some of the life forms off of that planet and send it to another planet. Now, we had a meteorite that was found in Antarctica. It's called ALH 84001. And it was noticed it had the same chemical composition as was found by the Viking spacecraft at Mars when the Viking spacecraft had landed there in 1976. So we had a chemical signature for a Martian rock. And when it was examined closely, it was found to have these so-called aromatic compounds on it, and also a slight magnetic field to it too, which is kind of surprising for Mars having a relatively weak magnetic field. But in its earliest days, it may have had a magnetic field. And the presence of these aromatics plus some cell-like apparent fossilized creatures were on it too. However, it's been stated that they could be just a natural geologic formation.
Right. Okay.
And so it's possible that something struck Mars where it had life and sent it to the Earth. This was an asteroid that was, a meteor that was found in Antarctica, what are called Allen Hills. This is why it's called ALH. And we know that the layer of ice it was in indicates it landed 13,000 years ago. And from the amount of wearing away from solar wind, tells us that it was actually in space for about 16 million years.
It was in space for 16 million years.
It was in space for 16 million years, right. And finally came from Mars and hit the Earth then 13,000 years ago. And we found it in 1984. And it has this bizarre chemistry in it.
But that still is not proof that there was an ancient civilization on Mars. Is that?
Oh, no. Okay. This is extremely primitive life. This is more primitive than we've ever seen on our. Yes, if it is life. But I don't remember her name, but an astronomer a few years later did an active search on the Martian surface using images from the Viking orbiter spacecraft, and she pinpointed a couple of craters on Mars that would be that indicate that an asteroid would have struck and with enough force to kick rocks off of Mars and let it to go to escape velocity, so it could roam the solar system and eventually hit the Earth.
Okay.
There are 2 craters on Mars that match that particular time period that appear to have the enough impact force to allow that to happen. And I don't know why in the world we have not scheduled a spacecraft to land at either one of those.
Right.
because it should be a very interesting spot to go to. If I were in charge, that would be my first priority.
Yeah. And this new rover that's going to Mars has a helicopter, so maybe we'll get something out of that. But I was just wondering if either of you have ever examined photographs of Mars and seen any indication of any ancient life that may have existed there. Well, I guess what I'm getting to is the so-called, to use that term, face on Mars. And if either of you give that any validity.
No, no. It's people are biologically engineered to look for faces, and whenever they see anything resembling something like a face,
right?
Yeah, we tend to say there's something. But no, the face on Mars image was from, I believe, 1976. Then we had follow-up images in decades later, and it looked nothing like a face. There's nothing on Mars that suggests from imagery, from orbiters, that look like anything unnatural, despite what you might see on the internet.
Right. And then, of course, the conspiracy theorists say that the photographs have been doctored, altered, censored, but... you guys have telescopes. Okay, but you have telescopes, so you can see firsthand yourselves what's going on there. And I was just wondering if either of you have ever seen anything that made you question the official NASA story. Because I'm not convinced.
Now we're fortunate that we have Mars coming close to the Earth in October of this year.
Okay.
I believe the closest approach is the night of October 7th. And we will get some good views of it. It'll be the closest approach until the year 2035, by the way.
Oh, wow. Okay, great.
So we've got it's a nice, good time of the year to be viewing planets, because the year is usually a lot steadier at that time of year than it is at any other time of year. So we're planning on, hopefully the virus will let us do outreach again and be able to show off the red planet. And we can show people the polar ice caps, the polar hoods, even the so-called orographic lift clouds. Mars just happens to have the largest mountain in the solar system. It's 2.5 times higher than Mount Everest.
Mars has the largest mountain in the solar system?
Right, it does, yes. And the largest canyon, too.
And the largest canyon.
It's 5 times deeper than the Grand Canyon and can stretch all the way from New York to L.A.
And you see this in your telescope?
We can see those features there. Yeah, right.
Mm-hmm. And I just was on NASA's Instagram page this morning, and they come up with something called What's in the Sky each month. And I think, Darren, you wanted to mention this. What's visible in the evening sky right now are Venus, Sirius, Betelgeuse or Betelgeuse, the Milky Way, part of the Milky Way. That's in the evening. And then in the morning, you can see the Moon, Mars, Jupiter, Saturn, Altair, Fomalhaut, Antares, and the center of the Milky Way.
Well, that's one at a time here.
I'm sorry. I had made a list. Go ahead.
Generally, you're right, but some of those not so much. The main thing to see these days in the evening is Venus. Mm-hmm. And the later you look into the calendar year, I think Sirius is pretty much going near the sun. I haven't really looked recently.
Yeah, it disappears in May.
Yeah, so
right, it disappears in May and reappears in August.
Yeah, Venus is well placed. It's a prominent beacon in the western sky, and it will not twinkle. And then the other planets in the Milky Way, by the way. Forget Milky Way if you're anywhere within 50 or 60 miles of Chicagoland.
Right.
The sky glow completely wipes out Milky Way.
Yeah.
If you're in a rural location, in a area away from towns, then you can see Milky Way if the moon is not up or if it's not real bright. But in the morning sky, it's a lot more interesting because you have 3 planets, prominent naked eye planets. You have Jupiter, Saturn, and Mars. And they're kind of doing a dance. Mars moved by the 2 planets in the last several weeks.
Now, when you say morning, what time are you talking about?
4 or 5 a.m.
Okay, basically. So right before sunrise.
It's up in the southeast. And the key here is to look to make sure that the stars or the objects are not twinkling. The planets, as a general rule, will have a steady light, whereas stars will tend to twinkle a little bit due to the atmosphere and the fact that they're tiny pinpoints, even through a telescope. And so Jupiter and Saturn, especially Jupiter, would be very prominent in the southeastern sky, and Saturn will be to its left. And then quite a bit to the left of Saturn is Mars, and it's going to become increasingly bright over the next several months through October and be brighter or about the same brightness as Jupiter is now.
So Mars is going to be really close. Hang on, let me just ask this. Mars, Dan mentioned, is going to be very close in October of this year. Remember in 2016 when Mars was close? And I remember distinctly because I was at Joshua Tree National Park in California, and Mars was gigantic. Is it going to be closer than it was in 2016, Dan?
Actually, I believe it is not quite as close. Let's see. I think you're confusing it. I think, I'm trying to remember. Let's see. 2018, 2016 was a close approach. Yes, it was a little bit closer then than it will be this time, but only by about 1% or so.
Okay, so similar to the way it looked in 16.
Basically the same brightness, yes. I want to point out one more thing, though, about Venus, because on the nights of the 20th and 21st of this month, it's just barely above the planet Mercury. And the following two nights, it's just below, Venus is just below Mercury. So it's an opportune time to use Venus as a beacon to see Mercury, which is not often seen by most people. In fact, I think it was said that even Nicholas Copernicus never even saw Mercury once in his life. But this will be an opportune time to use Venus as this brilliant beacon to see Mercury. Again, on the nights of the 20th and 21st, Venus will be slightly above it. And then the next two nights, Venus will be slightly below Mercury.
And which part of the sky do we look in?
Yeah, this is the west-northwest and around 9 o'clock.
West-northwest around 9 p.m.
Yeah. Right. They'll be about 8 degrees above the horizon at that point. So have a nice clear horizon. But Venus is easy to see. Then look for Mercury just below on the 20th and 21st. Look for Mercury just above on the 22nd and 23rd.
Okay. And Dan, you haven't told us about your George Lucas story. I completely forgot. We got to hear that.
Can I interject?
Yeah,
for just one
go
second,
ahead, Darren.
I want to clarify one word you said that doesn't strike me right, and that was the word gigantic when you referred to Mars.
Hey, I'm an amateur.
Every single planet. Yeah, I know. I'm just going to clarify.
Yeah, go ahead.
All the planets are pinpoints to the naked eye. You can never see size in any planet. It's purely the brightness that we perceive.
The brightness. Okay. Thank you. Okay, the brightness.
Except the rare case.
Whoa. One at a time.
Except the rare case of seeing Venus when it's near by the Earth as a thin crescent. People with the best vision might have a chance to see a crescent shape of Venus in a twilight sky. But I've never been able to see that. But there have been reputable reports of people seeing the Venus crescent to the naked eye, but binoculars really would do it. But so I just wanted to clarify and I say that because there was that big crazy hoax about Mars being the same size as the moon, in 2003, which was nonsense. So there is no size to the eye on a planet except for brightness. That's all we perceive. That and color is all we're going to perceive when we see the naked eye.
Color. Okay, so when I saw Mars, and it was a very memorable night for me because I met Robert Bauval for the first time, who I idolize, and he interrupted our conversation and said that he was just so distracted by Mars, and it was right there, and it was an incredible night. But it did look, it just the circumference of it, looked very large. And you're saying because of its closeness to the Earth, it appeared
No,
brighter?
because of how small the disk is in the sky and the resolution limits of human vision, there's no way to see anything other than a point to the naked eye.
Okay. No, but I'm trying to understand why it looks so bright.
Because it's against the blackness of space, it's not hard to be bright. And the fact that it's relatively close to the sun, compared to the outer planets anyway, it's going to be shining brightly because it's that's just the way it is. It can be as bright as just a Saturn or dimmer than Saturn like now, or it can be brighter than Jupiter. It all depends on how big the disk appears in the sky. And we usually use the term arc seconds. How many arc seconds is the diameter? And the most it can ever hit is 25. And I think it'll be about 21 this October, if I'm not mistaken. 21 arc seconds, which is still, it's still 60 arc seconds is a 60th of a degree. So it's still completely, it would be like looking at a dime about 800 feet away or something like that.
Got it. Okay. Thank you for clarifying that. So back to the George Lucas story. And Darren, I'm sure you've heard this several times, right?
Yep.
Okay, Dan, give us the abbreviated version.
Okay. Well, I was instructor at Adler Planetarium's old optical shop. They don't have it anymore, unfortunately, but back in the late 70s, which of course is when the original 1977 release of Star Wars came out. Now, a few months before the movie was released, there was a novel version, there was a book version. I finally saw the movie about 3 months after it first hit the theaters. I was very, very busy. The optical shop was, at that point, was very hectic. I had many students, and I didn't have a whole lot of time to go to a movie theater. But eventually, I made it by the end of August of that year. And one time, I came back from the shop. I can remember it very specifically. It was the night of November 1st of that year. So this was about 5 months after the movie came out. And I had 17 students in the shop. And I'm trying to get them all to this incredible degree of accuracy that we demanded of ourselves to get the students to get their telescope optic to, so they're completely optimized. We had unsurpassable optics, and we had a big reputation because we'd had our optics tested both at the Kitt Peak National Observatory shop and also at the University of Arizona's optical shop. But there's a big even today, these are the standards for getting telescope optics together accurately. In any case, though, I had to relax myself, and I picked up the novel version a few nights earlier, and I thought, well, I'll go through the pictures, and see all the nice pictures in the book there, reminding me of the movie, and I'll kind of relax myself so I could get to sleep because I was exhausted. I was fatigued, but I wasn't sleepy. And I needed somehow to relax myself, so I thought that would do it. Well, I finally decided, well, why don't I just start reading the novel? And I got to page 16. Now, you might remember there's a scene in the movie early on where R2 has run away, and Luke is frantically searching the horizon with those carefully cleaned set of macro binoculars, as it says in the book. And finally it says, for long moments he stared, wishing all the while he had a real telescope instead of the binocs. Well, it hit me in less than half a second. Of course, the guy who's writing that line is telegraphing his own wish for having a real telescope through the thoughts of his protagonist, which of course was Luke Skywalker. And I thought, how is he going to get a real telescope unless I make one for him and get it sent to him? And this is a total shot in the dark. This is another thought that's coming through. At the same time, it was very easy to notice the increase in the attendance at the planetarium after that movie came out, and people were far more interested in seeing the heavens and learning about astronomy as a result of it. I thought, what a shame if he really was, of course, this is George Lucas, really wants a good scope, and he never gets one. Well, maybe I can change that. And I thought, well, I'm going to do this. It's going to be my own project. It's going to be absolutely no one else is going to have anything to do with this. And I'm going to try and keep the identity of this person I'm going to build a telescope for completely secret. And so I set about the next 2 months just designing it. I was working on another particular project at the time, but it was a very important project. But as soon as that one got done, which was now January of 1978, I then ran over to a place where I could get one of these discs, a 10-inch disc, because I thought that what George should have is the largest telescope that one person can fairly easily handle. Now this scope would have 900 times the light gathering power of the eye. It would be able to see galaxies over 300 million light years out.
Wow.
Very far, far away, as it says in the opening line of the movie. So I started working on it there early in January of '78, and I finally got the primary optics done. As it turned out, on my 30th birthday, which was March 23rd, and I still had to, of course, gather the rest of the components together, which I was doing over the next several weeks. I'm still wondering, how in the world am I going to get it there? These people keep their hideouts, hideouts. You don't find them.
Right.
They don't let themselves be known as the where to track them down. So this story may be the poster boy for you make your own break. I had originally thought that, George might have all the resources to get his own scope at some point. And just abandon the project entirely from the very beginning. But I thought, no, I've got to do this. and so the big break came when I found out that the scene where they plug in R2 to show the rebel pilots how to get through that channel to the vulnerable exhaust port to get the proton torpedoes down in and blow up the whole Death Star. Well, that scene was shot at UIC.
And UIC is?
University of Illinois, Chicago.
Okay.
And down there at Circle Campus. And it just so happens to have been done by a fellow named Tom DeFonte, the software for it. And he had also done some of this work for the chemistry department so they could show molecular structure in 3D and in motion, which of course is what this scene was all about, 3D and in motion. And it turns out that the chemistry department was writing a phone book. So I called them up and they gave me Professor DeFonte's direct line. And I told them that, I was making this scope, how I got the idea and what the scope could do. And I just don't have an address. It's almost joking. And it'd be too bad if George never got a good scope. And so he said, well, that really is a terrific idea. And he said, you need to talk to Charles. And he gives me this phone number. And a few days later, I called that number, and the girl on the other end answered, "Good afternoon, Star Wars. I'm there." How about that? And I'm thinking, maybe this might work. And I kind of let out a groan when she said that Charles was on vacation for a couple more weeks. And then after a little bit of a gap, she said, well, is there anything I can do to help? And knowing I was going to tell Charles about the secrecy I was holding it then, and nobody was guessing as to who this was for.
Uh-huh.
And this is a big project. Nobody's guessing, And so I said, do you think you can keep big secret? And she's like, huh? And I went into a description of the scope, how I got the idea, and we got into a conversation of what the scope could do and a little bit about the movie and stuff. And I said that Professor DeFonte said that if I talked to Charles, I might be able to ascertain what the correct address would be. And after a little bit more conversation, she said, that really is a great idea. Here's where you send it. I had it just like that.
Wow.
I was amazed. And 7 weeks later, I got a call. I answered optical shop, and I heard someone say, "Hello, is this Daniel Joyce?" "Yes." "My name is Jane Bay, and I'm the executive assistant to George Lucas, and I would like to thank you for sending out this magnificent telescope for George. You have the whole office going wild here. Nobody has ever seen anything like this."
Wow.
It just so happens that the scope was first noticed as it arrived by the movie's producer, who was Gary Kurtz. He decided, even though George wasn't even there yet, to open up the crate. They weighed 308 pounds, I think, together. I shipped it out by an outfit then called Flying Tigers. And she said, "You should have seen the look on his face when he got those crates open," because I had signs on it. One thing, how I got the idea, that quote from the book,
Mm-hmm.
and the other one describing the fact that it's 900 times the light gathering power of the eye. Can see galaxies over 300 million light years out. So they see all this, and they, believe it or not, before George got there, they actually had that scope set up by the instructions I had inside those crates. They had the whole thing was set up by the time he got there. That was just an electrifying moment.
I'm sure.
To say the least. Yeah.
And you have a signed photograph, an autographed photograph of Mr. Lucas with your telescope, and that will be part of the slideshow of this episode on our YouTube channel. Please like and subscribe.
Yeah. He sent that photograph about 2.5 months later with a donation of the planetarium of $3,000. And
wow, that's awesome. I love that.
And the best testimonial you'll ever see in your entire life.
Great.
It was wonderful what he said about it. And 7 years later, he invited me out to as a consultant for the building of Skywalker Ranch Observatory. And we're going to have the 35th anniversary of that this coming October, just as Mars makes its super close approach here. So it's going to be very interesting. I'm hoping the crisis from the virus is over by then, because I've talked with his executive assistant. It's a new one now. Her name is Connie, and about the idea of coming out then, and they're good about the idea if the crisis is over with by then.
So what goes on at this observatory? Would you tell us a little bit about it, and then we'll wrap up?
Okay. Together with the chief architect of Skywalker Ranch, for 3 months we designed what we wanted to have in this observatory. We wanted to have it so that there were no materials which would trap heat and create unnecessary air currents. They even had the walkway to it is pea gravel. They didn't even want concrete, to suck up sunlight during the day and have it during the night. Most of the structure is metallic, which throws off its heat very, very rapidly after the sun goes down. There's only a slight amount of concrete. Most of that is in the pier that comes up from the ground. It was stuck down about 6 feet so it could gain stability and come up to a point where when we attach the pedestal, the eyepiece of the telescope would be right at George's eyeball height when pointed at the highest point in the sky. So he would never have to climb anything to see anything through the scope, and it could get to within 3 degrees of the horizon. So everything came out perfectly with that observatory. It's just wonderful. What
goes on there now?
So right now there's a club they have there at the ranch. It originally had about 30 people in it. I understand now that Disney's taken over. it's more like 60 or 70 people are on this thing who have been trained how to use a scope and can use it at their convenience. And they do have guests that come there. I understand Clint Eastwood has even looked through the scope, from what I've heard.
Mm-hmm.
So they've there's a fellow there who's in charge of the overnight security, and it said that his name is Craig, and it said that every clear night on his rounds, he will open up that observatory and at least look at something.
Oh, cool. Cool.
So it does get used on virtually every clear night. Yeah.
Mm-hmm. Nice. That's wonderful.
Yeah.
So is there anything that we haven't discussed that either of you would like to mention now as we wrap up?
Yeah, I'd like to talk a little bit about, just for a moment. Yeah. What I do at the camp in Michigan every summer.
Yes, tell us.
Yeah. It's pretty unique in that it's the only place I know of where kids can be sent somewhere and then they can see views of the spiral arms of a galaxy, for example, because the place I do this is dark, and with a large telescope and me as the guide, I can show them, galaxies, nebulae with color, beautiful views of the planets, and do sky tours of the night sky, and also let them use telescopes because we have a fleet of 8-inch telescopes. And I don't know of any other place that can really do this. Let's say you go to Adler, and the Adler just got a new large telescope, very high-end, expensive telescope. But if you have someone look through it at the Whirlpool Galaxy, for example, they will not see the spiral arms of the galaxy because of the light pollution. Whereas if they look through what we do in Michigan, they will see the galaxy in all its glory with the spiral arms and the companion galaxy and so forth. And
well, that's a really good point you mentioned. So why would the city of Chicago, I know that the Adler Planetarium is privately funded, but why would they go to the effort of having such a high-tech telescope in an area of the country that has such, I don't want to use the word bad, but inclement weather? Well,
that's where it is. And they can afford to have a large observatory, and they can still do a lot with it. If you put a camera on it, you can still see these spiral arms that I mentioned, but it would be you'd be looking at a computer screen.
Right.
And there's a lot that can be done with it. But visually, it's quite limited as far as the deep sky objects go. Faint galaxies will become completely unobservable at all times through the eyepiece. But they can show the bright planets pretty nicely. But they're still limited by their location, and the heat environment causes images to blur. It's really not an ideal location,
right,
for many observing setups. But what I have in Michigan, or anyone really going out into a dark rural location, can see so much more with their telescopes than what they would see in a light polluted location like Chicago.
Yeah,
it's really the location.
Dan?
When I sent the scope to George, I did have instructions with it, and also said that, okay, it will see those galaxies, but not if you're near city lights. Mm-hmm. I had to explain, you have to be pretty far away from the lights. Fortunately, Skywalker Ranch is far enough out that you can see out 300 million light years.
What town is that technically located in?
It's called McCaskill, California.
Okay.
It's about 20 miles northwest of the Golden Gate Bridge.
Northwest of the Golden Gate Bridge. Okay.
20 miles northwest.
And Darren, I'm sorry, did you finish what you wanted to say about Camp Eberhard, or would you like to give us some more information?
Well, I was simply pointing out that this is fairly unique in that kids can see the night sky through large telescopes and see views that they can't get anywhere else. You go to Adler, you have the limitations I just mentioned. If you go to a school or an astronomy club at a school, you have smaller telescopes with parking lot lights and teachers who don't know anything near what you would really need to know to show things like this. And you have to deal with the fact that it's at night. School meets during the day. So really, there's not any other equal to what I do in the mission at Camp Eberhard, that in this region of the country where kids can be, other than going with their parents somewhere to like a star party, which are usually held in dark sky locations. And
you
so
guys do that. You guys go to these star parties. Would you tell us a little bit about what they are?
Yeah. All right, Dan, go ahead. Since
you go to Florida every year.
Right. The Winter Star Party has been in existence, I think, since the mid-1980s. I was first invited to it in 1990 myself.
And where is that located?
It's at Scout Key, Spanish Harbor, Florida. It's about 35 miles from Key West.
That's far out there.
So it's way out there, and you have the ocean and the Gulf of Mexico around you. That's it. There are no lights.
And you guys drive your telescopes down there, right?
Yeah, right. We have big vans, and we can do it. And we bring the big scopes down there, and it's well worth it. We have about 5 nights. I think every night was clear this year. It was just before the virus crisis hit.
Okay.
So there were no restrictions.
And can anybody go?
You just have to sign up maybe a month or so in advance with the Southern Cross Astronomical Society. They're the ones who operate.
I'll put a link to that in the show notes.
Right.
But that's one of many star party events.
Yeah, right. They're the outfit that does it. And well, unfortunately, they got hit hard by hurricanes recently. And as a result, I can no longer conduct my telescope making workshop down there, which was a lot of fun to do because it wiped out the plumbing and the electricity at the site where we designated having this workshop. It's just gone. It's just not there anymore. And eventually they want to get it built up. Now, these are Scout campgrounds. Boy Scouts have the western end, the Girl Scouts have the eastern end. And that's why it's called Scout Key, by the way. It's right by the way, the Key Deer Refuge. Among the smallest deer in the entire world live there at Big Pine Key, which is the next key over to the northwest of the site. And they're beautiful deer to look at.
Beautiful
there
deer.
are many. Yeah, they're wonderful. There are other wonderful sites, and you have water sports there too.
Mm-hmm.
And the third largest coral reef in the world is just offshore.
And this is all in Florida, in the Florida Keys.
Right. Yeah.
But there are many star parties throughout the country. It's not like you have to go to that one only. There's a few in Illinois and in neighboring states. So it's not like you have to drive many states away to get to these.
And these are all open to the public? You just have to sign up and then show up?
They have websites. You can sign up easy.
Okay. Great. Oh, is there anything else that we haven't covered?
Well, I do want to think about the project I was working on just before I sent George his telescope.
Okay.
There was another 10-inch diameter job, and I did it for a fellow who both of us had worked with at Sternin. His name is Dan Troiani. His nickname is Mr. Mars.
I know him. Don't I know him?
I'm not sure. Because if you've had any contact with the Sternin Center, you probably ran into him. But in any case,
I think I met him there one night when you guys set up your telescopes. Right.
So his scope, the problem was he made it a 10-inch f6. This is it's the same size as George, except it's about another foot and a half longer. And he got the optics 6 months later than what they said they were going to. This outfit in California said they were going to deliver it in. Turned out the owner had become almost deathly sick, so there was a problem with that. And also when it came, It was only good for out to 8 inches, and then it had no correction, which is faulty. So I promised him I would correct that situation. And I got that done middle of the first week in January. And just about maybe 2.5 weeks later, he comes by and he's got a sketch which he made at the eyepiece of Mars. And Mars at that point was about 120 million miles away. And he's showing detail as if it was at one of the close approaches, like when it's only 35 million miles away. And I says, I know this is a good scope, Dan, but geez Louise, did you do this from memory from the last time you blasted off the surface of Mars? Do you live there? I mean, this was so good. This was really terrific detail. Anyway, eventually he made a sketch of Mars. This was in December of 1979 by this time. And he sent it into the coordinator of the Mars section of the Association of Lunar and Planetary Observers, who happened to be the director of Lowell Observatory in Arizona at that time. And he's looked at it. He wrote back to Dan and he said, you have found what we call the Rima tenuis, the little scarp on the Martian North Polar cap that had been seen in 1888, again in 1901, 1903, and 1918. And not again until December of 79 from the corner of Wrightwood and Monitor in the northwest side of Chicago. He says, this is incredible. But anyway, he was able to verify it using the big 24-inch scope at Lowell. And he said he admitted he had looked for it for 20 years using even the 82-inch diameter scope at McDonald Observatory in Texas. One Martian year earlier, it had been the Viking 2 spacecraft had been directed to specifically look for this feature because it was a seasonal thing. So it was the right point of the Martian year, yet it did not see it. It did not pick it up, yet Dan picked it up one Martian year later. And to top that off, 2 months earlier, Dan had done a sketch of Jupiter. That turned up on the cover of the journal of this particular organization with the caption, "Crucial discovery of the first disturbance in the Jupiter South Tropical Belt, or zone rather, since 1944. And the great thing about that was that Voyager 2 had passed the planet just a few weeks earlier and did not see it. So on 2 occasions within a couple of months, Dan had beat spacecraft observing from the corner of Wrightwood and Monitor in the city of Chicago with a custom-made scope. Eventually Dan became the coordinator of the Mars section. But in any case, though, he was so addicted to looking at the planet, I finally said, well, it must be because he's homesick. That's maybe his home planet.
Right.
That's maybe his home planet. That must be it. So he's getting the title of Mr. Mars.
Mr. Mars.
So when it comes around again in October, we'll probably have him there with us on the public outreach night. That's for sure.
Nice.
And he'll describe in considerable detail what's all there.
Okay. Great.
Yeah.
Thanks for sharing that with us. Is there anything else before we wrap this up?
All right, one more thing. Because Dan was in that organization, he met up with a couple of people who were really into studying Mars. They were both South Floridians, and I eventually made optics for them. And George might get jealous because instead of just 900 times like getting Mars, he thinks they have 2,400 times. Yeah, right.
Nice.
And they weigh 48 pounds, just the glass.
Just the glass?
Yeah, right. And with them, I think I showed may have showed this image to you, Laura. A side-by-side comparison.
Yes.
Of the apparition of Mars back in 2003. Yep. And Hubble's images are there, and Don's images are there. And guess what? They look the same, even though Hubble was supposed to out-resolve every ground-based telescope. But happily, I can say we matched it. and we have a lot of fun with that.
There you go.
And
you are a treasure, Dan.
I mentioned earlier about the largest mountain in the solar system.
Uh-huh.
It happens to be in a couple of those images.
Yep.
It's on Hubble image, and on the Don Parker image.
On the Parker image, right? And those will be in the slideshow on YouTube.
Yeah, just below the center of the planet, you can see this like bright circle,
mm-hmm.
and that's the base of the mountain.
Okay, great.
Yeah.
Darren, did you have any closing thoughts?
Well, there's a lot to talk about, obviously, for perhaps another time.
Sure.
I enjoyed being here, and the night sky is an amazing thing. I encourage listeners to go up and look at it, learn the night sky with some simple apps or star maps, learn the planets and how to watch the dance of the planets. It's a fun thing. And to just educate yourself and discover the hobby of astronomy. It's an amazing thing. It's been a passion of mine since I was a little kid, and I'll always have this passion. So I hope other people can share it and discover this passion moving forward.
Well, thank you both. Thank you both for everything you've taught me, for sticking with me, and for always informing me of what I can see.
You're very welcome.
Here in Chicago. I really appreciate it, and I look forward to staying in touch. And both of you can be found on Facebook. That's another thing I will add to the show notes is your Facebook accounts, where you post a lot of interesting information about astronomy. So I am going to read the outro. Please visit the website Speaking of Jung, that's JUNG.com, for more information on everything that was discussed in this episode. There you will also find all of the previous episodes of this podcast, which are available to stream or to download for free. This podcast is also available on Apple Podcasts, Stitcher, Google Play, TuneIn, Spotify, and iHeartRadio, and it will be available later on our YouTube channel. You can also listen to this episode on your Amazon Echo device, simply by saying, Alexa, play Speaking of Jung on Apple Podcasts or on TuneIn. Just be sure to pronounce Jung with a hard J. So with special thanks to James A. McDivitt Elementary School, and a special dedication to XAI Archangel Musk, this is Laura London, and you've been listening to a special quarantine edition of Speaking of Jung.